And I think we can open the space for questions to all three presenters. Does this work for you, Alexei, if you can? Yeah,
definitely.
So I see here a question for Wei-Ning on the chat. So please, you can either, for all the attendees you can either add the questions on the chat so that the presenters can read them and then answer, or you can ask it yourself. So let's take that first question until other people think about more questions. So please, Wei-Ning, do you mind, like, if you want to, can read the question and answer it?
Yeah, sure. Let me read the question. So the question is pretty long, so let me just like summarize that. So Andy Chang was asking, there like with self-supervised learned discrete units, one is able to reformulate many speech problems into NLP ones. So he's asking, there are many algorithms right now that can learn self-supervised units. So from my experience, like, is there any difference on the self-supervised learned units from different algorithms, like in terms of the property or the performance on the downstream tasks? So yeah, I think that is a great question. And like some of this question, I would say like there are a lot of studies on this question. So the one study I would like to point out is the generative spoken language modeling paper, also like from Meta AI. So in that work, we were mainly benchmarking the performance of discrete units for generative modeling, like language modeling. So in that paper, we compare VQVAE, which learns discrete units, but the model is trained with the reconstruction objective with Wave2Vec 2.0 and also with Hubert, both of which are trained to infer the structure information from within speech, but one use contrastive loss and the other use predictive loss. So we do find that although like different algorithms learn discriminations, their property would differ a lot depending on what kind of like task you use. So for example, when you use VQVAE, then because it is trained to reconstruct the original signal, then it will inevitably also learn like information like speaker aside from the content, which means that if you want to use it for, say, voice conversion, which is also one paper like described earlier today in this workshop, then it will fail to disentangle like speech information from the content. If you are meant to use like this unit for encoding the phonetic content. And on the other hand, like Wave2Vec 2 and Hubert would be more invariant to the speaker representation. Yeah. So yeah, of course, like there are also like other studies like showing whether like these units are learn information at the phone level or at the semantic level. So for example, like there are several studies from UT Austin from David Horwath's group, which shows like if you use like say grounding information, like visually grounded speech, then you will learn like higher level information like semantic level or word level information, as opposed to like nowadays most of the self-supervised learning methods will learn mostly like phone or cell phone level phonetic information. Yeah, I hope that answers the question.
Well, thank you so much, Wei-Ning. Any more questions? So I think there's a question for Alexei. Do you mind reading question and answering from Hangi?
Yeah, sure. So the question is, besides BYOL-like approaches, have other methods been tested in the setup for data to back, for example, Barlow twins? And the answer is, I have done some small explorations as to whether these kinds of approaches can work. And unfortunately, I wasn't able to get them to work and produce similar accuracies as I was able to get with a BYOL type approach. But I think, I haven't done a very thorough job of exploring this.
Cool, thanks, Alexei. Any more questions? If anybody don't need to write them, they can jump in and ask directly the presenters. So Wei-Ning, I think you have a question. So
I think there's one more question above for Alexei. So
oh, I'm sorry. Yes, I missed that one. So please go ahead, Alexei.
Yes, so the question is about modality-specific feature encoders. Do these modality-specific feature encoders encode the input data into the same dimensional features? And the answer is yes. so the transformer network itself for all different modalities is exactly the same with the same dimensionality, number of heads, and so on and so forth. So the feature encoders for, let's say, speech encode into 512 dimensions, which is then projected into 768 dimensions or 1024 dimensions for the transformer. And the same thing happens for text. You have an embedding table with the dimensionality of the transformer. And for vision, the MLP projects into the dimensionality of the transformer as well. I hope that answers the question.
Thanks, Alexei. Wei-Ning, do you want to go next?
Yeah, sure. So I think the question is about how we use discrete limitations to do to do emotion conversion. So for that particular model, we actually leverage paired data where you have like the same speaker speaking the same sentence but in different emotion. So what we did was to create like pairs, training pairs, by casting that as a machine translation problem. By first we can transcribe like the paired amused speech and neutral speech into a sequence of like discrete units, and then just like train the model as if it's like training a machine translation problem but like they share the same vocabulary. Yeah. So that way we can convert like from speech in one emotion represented in discrete units to the same like speech saying the same content in a different emotion. And after we train the model, we have another vocoder model that can convert discrete unit back to waveform. And that's how we generate the waveform I just played. I hope that answers the question. Yeah.
Thank you. Any other questions? I'm not sure if Odette is online. Yes, she's online, right?
Yep, I'm here.
Yes. Thanks so much for the great presentation and the great work. And I just wanted to let everybody know that you're also there for answering questions. So please, if you have questions for Odette or any other presenter, please go ahead. So if no presentations, for no questions, Alkamik, I just wanted to move the kind of the lead to Iwan, who is chairing the next session. So are you available?
Yep.
Yes, awesome.
Okay, hi everybody. So I think the next session officially starts at 2:30 according to the schedule. So maybe except for the presenters, maybe we can just take a short break and then I'll check in with all the presenters. If anybody's presenting, just send me a message. You can make sure you're here and we'll make sure everything's working. And otherwise we'll start at 2:30.
Thanks so much.
Thanks.